Hello guys, welcome to another session. In this session, we are going to look into lab for VPC. Whatever we have discussed in our theory section, we are going to work with VPC where we will look into default VPC along with non-default VPC, that is custom virtual private cloud. So let's jump into AWS Management Console and gets our hands dirty.
So guys, we are into AWS Management Console. Now we will move further and go to the VPC dashboard. To go into the VPC dashboard, we have two options. What we need to do, we need to come here and click on services, type VPC. So you can go it from here, or you can search here and you will find that networking and content delivery, or click on VPC. So once you click on VPC, it will take you to the VPC dashboard. So in this dashboard, you will find that we have a one VPC, 6 subnets, one root table, one security group, one network ACLs. So these components we have already discussed. So you must be wondering that we haven't created any kind of a VPC yet, but why do it exist over here? So here the first point to remember comes. So what happens that whenever we are creating an AWS account, on that time AWS create a VPC in each region. That I will show you, and this VPC is default VPC. So let's look into that. Once you go inside that, then you will find over here there is a flag mentioned default VPC. Yes, so that means it is a default VPC. But when we create a custom VPC, then you will find that this flag is set to be no. Now we will move to the other region and we will look into that. Is there any VPC is also being created while creating of AWS account? So we can go to any of the region. For example, US West North California. If we will go there, then we will find that there is another VPC is also being created while creating the AWS account. So it has created a VPC in each region. See here, the number is a little different. VPC-59 CDD E3E. So just remember this number. And what was the number we were having in North Virginia? I will show you. If you come here, then you will find that this number is different. So here you will find that 7B3B4F01. So now moving to the dashboard again, and you will find that it has 6 subnet. Why? Because it has this region, North Virginia region, had 6 availability zone. That's the reason it has 6 subnet. If you go US East Ohio, so here you will find that it has 3 subnets because it has 3 availability zones. Now we will move further, and again we will went back to North Virginia region and we will go inside the VPC. So we are into the VPC and we can go inside it and we will tag it. So you can give a name so that it would be easy to recognize that. So you can give it a name default VPC. It is really a good practice to provide the tagging. Now done. Now we will go to the dashboard, and here you will find that we have subnets. And why it is being 6 subnets? Because this region has 6 availability zones. It is also a good practice to tag the subnets as well if you want to do that. So it would be really easy to get to know about what this subnet is and from where it belongs to. You will tag it as well. Come here, tag it, give it a name. Subnet AZ1, subnet AZ2, subnet AZ3. So we can tag it like this way. Tagging is really very helpful when we want to troubleshoot. These subnets, you can find that it is being associated with the same VPC. So now here you will find the details about the subnet. So here you will get the description that what is the subnet ID, what is the state, which VPC it is being associated with. So here you are getting a number that is 4091. So you must be wondering how this number is being given. So let's discuss about some of the math. If you look into IPv4 CIDR, this one, then you will find that it has given 20/20 and it has total number of 32 bits. So that means 32 minus 20, we are having 12 bits. Now understand the math. That means we are having in hand 12 bits. On the basis of that, we can generate the IP addresses. So now I will open a calculator. So if we will find that 2 to the power of 12, that will give us a number 4096. But here we are getting 4091. If you look into that, 4091. Why is it so? Because 5 addresses which AWS will not provide and they will keep it for their usage so we can't use it. The top 4 and the last one and the top 4. So you should remember that the top 4 Amazon will keep it and the last one Amazon will keep it. Between that you can use any one. So that's the reason 4096 minus that 5 addresses, the top 4 and the last one will return a 4091. So that's the reason you are getting IPv4 4091. That means these number of IP addresses you can allocate within this subnet. So just remember that. And the other information you will find over here is that flow logs, which we have discussed earlier, root table information which is being associated with this subnet, NACL tag, the tags which we have created over here, it is being reflected, and sharing, is this subnet is being shared anywhere. So it is not given the information because we haven't shared it. So now moving further, we will discuss about root tables. So jumps into the root table. So here you will find that this is a root table which is marked as yes in the main. That means it is a main root table. If you remember that we have discussed about main root table in our theory section, you can also tag the route table over here with the name called main root table. And now if you remember this diagram, then you will come to know that we have an entry over here which is being mentioned like 10.0.0.0/16, that is representing the local. So where this entry happened, let's look into that. Then there is a tab called roots. If you will look into that, then you will find that we have an entry over here. Like here we are getting 172.31.0.0/16, and that is representing the local. This root table has an also entry of internet gateway. So you must be remembering the theory session that why we use route table. So it will be used to route the traffic. And this route table is associated with the implied router, and router can be used to route the traffic with the help of this route table. So by default you will find that it has 2 entries. So the first entry is this one. So what this entry means, why it is representing as local, because if any of the traffic which is coming within this range, this is a CIDR block range which you will get over here. If you will go into the VPC dashboard, within the VPC, then you will find we have a CIDR block range, the same range which is existing within the root table. So if we are getting the traffic within this range, that means that is belongs to the local. So this is what this entry means. So basically this entry is for the local within the subnet. Now we will moving further and we will look into what this entry is. IGW or entry, that means so it is applicable all the IPs which is coming from outside apart from the subnet. So that means first entry for local within the VPC and second entry for outside the VPC. So you must be remembering we have discussed about internet gateway in our theory section, where we have discussed about whenever any packet is coming from outside of the VPC, it must come through internet gateway, and internet gateway is associated with the implied router, and implied router is associated with root table, where we can check that where this packet should go. One important thing which I wanted to show over here is whenever we are going into the edit, you will find you don't have a provision to delete the default local, but you have an option to delete the internet gateway. And this entry you can find in all the route table within the VPC, whether it is a default route table or whether it is a custom route table. The local entry should be associated within the VPC route table, irrespective of type, whether it is a main route table or a custom route table. This entry will exist. Why? Because it contains the IP address ranges within the VPC. Now moving further, you can check the subnet association within the subnet association tab. So here you will find it has 6 subnet association over here. So now moving back to VPC dash. So now here we have understand in this lab the default VPC came to know about what happens when we create an account with AWS. Then AWS by default create VPC in per region. We have also discussed about subnets. We have also discussed about root tables. So here I am stopping. In the next session we will do the lab to create the custom VPC. In the custom VPC, where we will create the subnets, root table, internet gateway, security group, network ACLs by our own, and then we will associate those components with the VPC. So this is what I wanted to discuss with you in this session. See you in the next session. Till then, bye bye, take care.